for example. And then the user should be able to interact with the tool through a GUI by doing inputs or reading the outputs. The architecture styles for considerations are Blackboard and C2. Blackboard consists of independent program accessing and communicating exclusively through a global data repository. And the C2 is an indirect invocation style which independent components communicate exclusively through message routing connectors. Uh, the strict rules on connections between components and connectors use some sort of layering. So this is the architecture option for the Blackboard. This is a level 2 architecture in where on the top we show the main components communicating through a data access to the Blackboard. And so the intent is that each of the methods post solutions to the Blackboard, so that with the idea that we come with a solution, a global solution. This is the architecture option number 2, a level 2 architecture of the C2. And at the top we show the clock and track file management manager state, sending notification to the main methods on the bottom. In each of those methods, send requests to the clock and track file manager state to get the clock tick or the current state of the system, so that they can perform each one of those their own functions. This is the class diagram, and here we can show the GUI. The GUI basically requires an end time from the user, so how long it will take to run. For example, you can input 30 seconds, 40 seconds, whatever you want, and then the GUI is going to send a request to the track file manager state to update that information, and then it also will output grid detection, track, and association information from the tool. Okay, I'm gonna go through each one of those in the demonstration. Currently, the track file manager state has the main states of the system, and the end time by default is 25 seconds. So once you run the application, by default you have 25 seconds, but at any time you can input your own end time and to replace that 25 seconds. The scene generator will handle notification from the track file manager state and will request to update the track file manager state with the grid information, and the detector here will get notifications from the track file manager state and the clock saying, hey, there's information available, and then the detector will update the track file manager state with the detection information. Similarly, the association and tracks methods will do their own requests to update their association and tracks. Just a disclaimer for the demonstration, I don't have the method of the association. I put the association function inside the track method. I didn't do that for simplicity, but I put it here for completeness. The pros and cons of the Blackboard is that the components post solutions independently and enable others potentially to solve problem with newly posted data or state. And normally the Blackboard is suitable for artificial intelligence application, and maybe you can consider this as one of those. The cons is that tractable solution may become difficult in large size, limit. So if you have a very complex scenario or pixel, then it might become very difficult to uh, obtain a solution. And then also a cons is that the center of attention on this architecture is explicitly structured shared repository, which may go against certain desire from the users and organizations to keep flexibility in development and maintenance of the tool and maintain independence between components. So sometimes if I want different people at different times creating these methods and functions, uh, having a blackboard might be a difficult thing to do um, because of the restriction of a shared memory. Okay, with the C2 style, the interoperability between the components or objects implemented can be implemented in different programming language, and so this is a highly desirable feature in any advanced simulation tool. Okay, as I was saying before, and it also supports product lines. Perhaps this is the main feature that I like. It's basically allowing the me to reuse this framework in another kind of application. It doesn't have to be a track file manager, and um, so it makes it easy to reuse in different products. Uh, and so this is something that any organization kind of looks for. What is constantly seeking is some kind of generic approach for different problems. And it also has a natural support for concurrent components, whether running on shared processor or multiple machines. So it kind of mimics embedded implementation where you can have a method in one processor and other methods in a different processor. So the cons is that the event routing across multiple layers can be inefficient. So this is something to consider at the time of creating any complex application with this style. Uh, this My selection for implementation of the Drag File Manager system is a C2 style uh, because it matches the desires from user organizations in the following areas. It supports, again, support for product lines. Each component may have its own thread of control, simplifying modeling and programming of multi-component, multi-user, and concurrent applications. It allows for no assumptions in regards to shared memory, as it would be unreasonable in composition to heterogeneous, highly distributed components developed in different language with their own threads of control, internal structures, and universe of discourse.